Bismillahirrahmanirrahim. At the beginning of the class, I need to take the attendance. As you know that in your exam, some marks has been allotted for the attendance. Okay. Now we are going to start. The topic is stress versus strain curve, inshallah. Okay. In the last class, we already got to know what is a stress and what is a strain. Now, and we also got to know that they are proportional to each other within the elastic limit, right? Within the elastic limit, according to Hooke's law, stress is proportional to strain, or we can say strain is proportional to stress. Okay. Now, if we put it in the graph, let us say we have taken a extensible wire. Okay, what we have done, we have taken an extensible wire. What do I mean by extensible? That means if you want, or if you apply some force on it, you can extend it. Okay, and upon removal of the force, what will happen? It will spring back to its original situation. Okay, within elastic limit, obviously. So if we put this on the graph, then we will see a line like this. Okay, this is the origin where both the strain and stress is zero. We know that when we do not apply any stress, that means zero stress. The strain will also be zero. So definitely the first point will be at zero. Okay, this is our first point. Now what we will do?
ওয়্যারটা কোথায় রাখছি?
ওয়্যারটা আমি দেখাচ্ছি। ওয়্যার সিচুয়েশনটা আসলে অনেকটা এরকম যে একটা রিজিড সাপোর্ট থেকে তুমি একটা ওয়্যার ঝুলাই দিছো এবং এটার সাথে তুমি চাইলে তোমার ইচ্ছা মতো মাস হ্যাং করতে পারো। ঠিক আছে, এটা তোমার ইচ্ছার উপর। তুমি চাইলে আরেকটু লোড বাড়া দিলা, সেটাই আমরা আসলে এখন করব। শুরুতে যখন কোনো লোড ছিল না, ওকে, there was no strain, no stress, 0 okay. Now if you hang some mass here, what will happen? It will extend a little bit, right? What will happen? It will extend a little bit. This is the normal situation, let us say. Okay, and when you hang the mass, what will happen? It will extend a little bit. So definitely there, due to the load, there will be some stress, and as it is elongated a little bit, there will be some strain. We can calculate it and we can put the value over here. Let us say this is our next point. Okay, for this situation. Now if I keep on increasing the load a little bit, okay, little, if you increase the load, then what will happen? It will keep on increasing. The length will keep on increasing, right? It will be extending continuously. So if I take different values, let us say for for this stress, this is the amount of strain. If I increase the stress now, for this I will get this amount of strain. Okay, so like that, if I take different value of strain for different value of stress, then what will happen? I will get this straight line. Okay, 0 to p. And we know that whenever it is a straight line with positive slope, this is a positive slope straight line, right? The relation between these two parameters is proportional. That is what we get to know from Hooke's law also, right? So this is according to what we know already, right? Now as you keep on increasing, you will get several points, and when you join them, you will get this straight line that is up to p. From, let us say, you reached p, and from p you have started decreasing the load. Now you at first we went from here to here, right? We keep on increasing the load, and what happened? The length expansion took place. Now if we start decreasing the load, what will happen? It will go in the reverse direction, right? That means from here, if I keep on decreasing the load, if I decrease the stress, then what will happen? The strain will also decrease. And what will happen when I have decreased all the stress? That means gradually I have taken back all the mass that I have hang over there. What will happen? The strain will be 0. That means these points will be followed again, and it will trace back to this origin point. Do you understand this one? And the object will come back to its original length. Okay, no stress, no strain. Again we will come back to this 0 point. Do you understand this?
Yes.
If we keep on increasing the load, then we will go up, If we decrease the load, we will come down, right? So this line will be followed within the elastic limit. Okay, now this point P, okay, is what we consider as the elastic limit. Okay, up to point P this happens, but if you go beyond the elastic limit, then what will happen? You know that the body will start to lose its elasticity, right? And what will happen if you keep on increasing the stress? It will not be a straight line anymore, rather it will follow a path like this. It will take a downward turn. Okay, it will take a downward turn and come to the point Q. And we know that we have a spring. Let us say we have a spring. We are extending it, releasing it, it comes back to the original situation. We exert a larger amount of force, it will extend more, and we release it, it will come back to the equilibrium position. Now if we keep on increasing it, what will happen? After the elastic limit, if you cross the elastic limit, the body will lose its elasticity, and what will happen? The body will not be able to regain its the original length, right? This is what we know. So as we have gone beyond the elastic limit, the body will not be able to come to its original shape now. Okay, so let us say you have increased the load and you have come to the point Q. Now from point Q, again you have started decreasing. Okay, from Q you start decreasing. What is expected? Okay, generally we expect that it will follow this line again and it will come back here. No, this does not happen. Okay, from this point, if you keep on decreasing the load, it will follow a path like this and it will come here. Okay, and you can see that a permanent deformation has been caused, right? When we apply a force that is beyond the elastic limit, then what will happen? The object will lose its elasticity and it will not be able to regain its original state, right? It might, compress a little bit, but it will not regain the original state. That means a permanent deformation will be caused, right? And this is the amount. If this point is T, then
স্যার আমরা যদি এলাস্টিক লিমিটের উপরে না যেতাম দেন কি হইতো?
এটাই তো বললাম শুরুতে না, ইলাস্টিক লিমিটের উপরে তুমি না যাও, ঠিক আছে? তুমি লোড বাড়াচ্ছ, এই লাইন ফলো করে উপরে যাবা, তুমি লোড কমাচ্ছ, এই লাইন ফলো করে আবার নিচে অরিজিনে চলে আসবা। ঠিক আছে,
ওকে ওকে।
তুমি জিরো থেকে লোড বাড়াইতে বাড়াইতে এই লাইন বরাবর উপরে গেলা, ইলাস্টিক লিমিটের আগে তুমি থেমে গেলা। ইলাস্টিক লিমিট থেকে ওখান থেকে আবার তুমি লোড কমাচ্ছ, এখন লোড কমাইলে তো স্ট্রেস কমবে, স্ট্রেইনও কমবে, তখন এবার কমতে কমতে আবার যখন লোড জিরো হয়ে যাবে তখন স্ট্রেইনও জিরো হয়ে যাবে। So within elastic limit, this straight line will be followed. That means the relation between them will be proportional to each other. A straight line of positive slope. এগুলা কোঅর্ডিনেট জিওমেট্রিতে তোমরা পড়ার কথা অলরেডি। আমরা দেখছি না যে একটা একটার সাথে যখন প্রপোর্শনাল থাকে তখন কি হয়, এটার মাঝখানে যে স্লোপটা সেটা একটা স্ট্রেট লাইন হয়, তাই না? উইথ পজিটিভ স্লোপ। আচ্ছা, তো যদি আমরা এটার উপরে চলে যাই তাইলে আসলে এই ঘটনাটা ঘটবে যে কিউ পয়েন্টে আমরা পৌঁছে গেলাম। তো তাইলে এখন হবে কি, এটা স্ট্রেস তুমি কমাইলেও এটা আর আগের মতো ব্যাক আসবে না, জিরোতে ব্যাক আসবে না। তুমি যখন স্ট্রেস কমাতে কমাতে একদম জিরো করে ফেলবা, দেখবা যে স্ট্রেনটা জিরো হয় নাই, একটা পার্মানেন্ট ডিফরমেশন রয়ে গেছে। ঠিক আছে, মেবি এটার অরিজিনাল লেন্থ ছিল 5 মিটার, তুমি এটার ইলাস্টিক লিমিটের বেশি এক্সপান্ড করছো এবং যখন এটাকে ছেড়ে দিছো তখন দেখতেছো যে এটা এখন কোনো লোড ছাড়া 6 মিটার হয়ে গেছে। তার মানে কি 1 মিটার পার্মানেন্ট ডিফরমেশন হয়ে গেছে, বিকজ ইউ হ্যাভ অ্যাপ্লাইড আ ফোর্স দ্যাট ইজ বিয়ন্ড ইলাস্টিক লিমিট। ডিড ইউ আন্ডারস্ট্যান্ড? এন্ড ওই যে 1 মিটার সেটা হচ্ছে এটা, এখানে স্ট্রেন আর 1 মিটার ডিভাইডেড বাই দ্য অরিজিনাল লেন্থ। ওকে, so now as you can see, if we continue to apply more, if we continue to increase the stress, then what will happen? Then the graph takes a zigzag path. Okay, এখানে জাস্ট অল্প একটু করে দেখাইছি, it will go up and down, go up and down, it will not go very much higher or it won't come very much lower, a little bit zigzag path it will follow. Okay, so and then it will come to the point R. Point R এর নামটা কি জানো? At the point R, what will happen? The body will start to lose its shape. Okay, already the elasticity is gone. Okay, now the body will start to lose its shape. Till now it was maintaining its shape. Okay, but now it will start to lose its shape. And if you continue further, এরপরেও তোমার শান্তি হয় না, তুমি আরো স্ট্রেস দিচ্ছ, at one point the wire will snap. তুমি তারপরও স্ট্রেস বাড়াচ্ছ বাড়াচ্ছ বাড়াচ্ছ, the wire will snap. Snap means ছিঁড়ে যাবে। ঠিক আছে, so that is the breaking point. We know that, right? That is the breaking point. Okay, so S is the breaking point, and the stress that is applied at this point, okay, along y-axis we put the stress, right? So S at this point, the stress that we apply, that is the breaking stress. Okay, and if you want to get the breaking force from here, let us say I want to calculate the breaking force from here. So I have to multiply the breaking stress with area of the wire. Why? Because we know that stress is basically pressure. Pressure is equal to force divided by area. So if I want to find F, I have to multiply P and A, right? So here P is breaking stress, A is area of the rope or wire, whatever you say, and F is the breaking force here. Understood? Okay.
Yes.
Now, this is actually this is going to vary. This point will vary from material to material, right? Okay. I have just shown a sample point that after elastic limit, the path is normally like this, and there a point comes where the wire snaps, or any object you keep on increasing the load beyond the elastic limit, then what will happen? At point it will break, right? That point is called breaking point, or breaking. The force applied at that time is called breaking force, and the stress that is developed within the body is called breaking stress. Okay, anybody has any doubt in this graph?
No.
No? Okay, good. Now the next topic that we have at the end of this page. Oh, before I go to that topic, I must mention that I'd like to request you to go through the lines of the books, right? I did not take you line by line, right? Through the lines I did not take you. I just explained it. Okay, if you understood the topic, then kindly read the paragraphs and let me know if you have not. I think you should do it now, okay? Because after the class you might forget to read it. So read now, and if you have any doubt, we can clear our doubts here itself. Okay? So I will give you.
কালকে বলছিলেন এটা পড়তে,
হ্যাঁ
কালকে বলছিলেন
হ্যাঁ হ্যাঁ, কিন্তু তুমি পড়ছো।
কালকে আমি হাফের বেশি পড়ছি।
ওকে, সমস্যা নেই, 2 মিনিট সময় নাও, এবং এখন আমার মনে হয় কালকে পড়ে যতটুকু না বুঝছো এখন পড়লে তার থেকে একটু বেশি বুঝবা। তো জাস্ট একটু দেখো, একটু সময় নাও। ওকে, তারপরে আমরা ইলাস্টিক ফ্যাটিকটা শুরু করে দেব, ঠিক আছে? ওকে তাহলে।
ওকে স্যার।
আচ্ছা, so nobody has any doubt, right, in the graph? Then we can talk about elastic fatigue. Now many times in our practical life we hear the words actually mental fatigue. Mental fatigue, do you know what is it, mental fatigue? I find it quite similar to the elastic fatigue. Okay, let us see what is it. If we continuously increase and decrease the stress of a wire, let us consider a spring. You have a spring, you are increasing, decreasing, increasing, decreasing, increasing, decreasing within the elastic limit. We are not going beyond the elastic limit, because if you go beyond the elastic limit, then what will happen? It will definitely lose its elasticity, right? But within the elastic limit itself, if you continuously, you are just expanding and compressing, expanding and compressing, don't you think it will have an effect on the spring? What is your opinion? Let me know.
Yes.
It will definitely have an effect, right? It will cause a kind of tiredness within the spring, right? The spring will kind of feel tired, okay? Of it is, you are expanding it, it is coming back to the original length. You are expanding again, it is coming back. Again, you are expanding, again it is coming back. It will kind of get tired, okay? Fatigue is kind of similar to this tiredness, okay? So if you continuously increase and decrease the stress of a wire, then its elasticity decreases, right? It will become weak. It will not have the same power to come back to its original situation, right? So in such situation, what will happen? Will it not come back to its original situation? It will come back, but now it is going to take a little bit more time. Previously, what happened? When it was fresh, energetic, you increase, release, then it will very fast it will come back to its equilibrium position, right? But now as it is experiencing some elastic fatigue, what will happen? You extend, release, it will take some time to come back to its original shape. This is what we see in our daily life also, right? We can understand, we can picture it in our mind. Okay, so let us go through the definition. If we continuously increase and decrease the stress of a well, then its elasticity decreases. As a result, after the removal of the load, the body does not regain its original state instantly. Previously, it used to regain instantly, but now it takes some time. This state of a body is called elastic fatigue. Okay, elastic fatigue. Now this one I like to compare with our mental fatigue. Okay, what happens? Let us say our employee has joined a company. Okay, he is fresh, he is energetic. No matter how much stress you put on him, he is always delivering, right? He is always completing the work you are assigning him. But if you continue to do that, if our employer continues to do this, that continuously he's keeping his employee in stress, then what will happen? At some time, that employee will experience actually some mental fatigue. Okay, he will become tired and he will not be able to deliver as fast as he used to deliver in the earlier cases, right? So this is called mental fatigue. Psychologists, they actually know much more about this. I just thought of comparing this one with our real life situation. Okay, elastic fatigue, so that it becomes easier for you to understand. Okay, uh, for human also there is a breaking point. There is a breaking point, right? It's like a spring, because if you keep putting on stress on somebody, there is no one actually in the earth who can take the stress up to infinity level, right? Infinity level stress nobody can take. There is always a breaking point for every person. So you have to know actually whenever you are putting some stress on some other person, you have to know that it should not be high enough to break that person. Okay, sometimes mental breakdown causes and the person goes, আমরা পাগল বলি, ঠিক আছে, অনেকে মানসিক মানে কি বলে এটা মেন্টাল ব্যালেন্স হারায় ফেলে, ঠিক আছে। সো এটাকে আমি বলি আর কি যে ব্রেকিং পয়েন্ট ক্রস করে ফেলছে ওর উপরে যে স্ট্রেসটা ছিল। ওকে, যাই হোক আল্লাহ সবাইকে সুস্থ রাখুন। So this state of body is called elastic fatigue. Did you understand the concept? What I mean by elastic fatigue?
Yes.
Okay. So at that time, the wire can snap at a lower load. So what happens here? Previously, when the spring was fresh, the breaking force was much higher. Okay, if you want to break it by expanding or snap it by expanding, then what happens? What you have to do? You have to apply a larger amount of force. But now, as you have, compressed and expanded it a lot, then what will happen? If some elastic fatigue has developed in this one has become tired of fighting with you. Okay, so what will happen? Now if you want to snap it, then what will happen? The force that you have to apply now is significantly smaller than the force that you had to apply in fresh condition when the spring was fresh. Here they are saying where I like to explain it with spring. I hope you can understand the similarity, right? Okay, so now the breaking load will be much more lower, correct? Okay, can I move to the next topic?
Yes.
Okay, then we have elastic moduli. Okay, we generally see or hear modulus. What is moduli? Moduli is actually plural of modulus. Whenever we are talking about one modulus, it is modulus only. And whenever we are talking about, there are several modulus, Young's modulus or longitudinal modulus. Then we have bulk modulus. Okay, so whenever we are talking about more than one modulus, we are covering them under one topic. We say it moduli. Okay, that is the plural. So elastic moduli, this one we get the idea from Hooke's law itself. Within the elastic limit, the stress is proportional to strain. So as I showed you, the stress proportional to strain. And if I want to put an equal sign, I have to introduce a constant. What constant they have put? What letter they used? E. Okay, so let us say the constant is E. So if I want to find the value or develop an equation for E, it will be strain. If I change the side, it will be stress divided by strain. Okay. Now this is what is elastic modulus. Okay. Now it will be different for different cases. Like for wear. Okay. In case of wear, what happens? The length changes, right? So for that, it is actually longitudinal modulus. Okay. That is also called Young's modulus. Whenever we are applying it for length change, Young's modulus, or it is also called longitudinal modulus, and it is expressed by y. And what is it equal to? We know that elastic modulus is equal to stress by strain. Longitudinal modulus is equal to longitudinal stress divided by longitudinal strain. Very simple, right? All you have to do is just add the longitudinal word. So longitudinal stress divided by longitudinal strain. Okay?
Yes.
Now let us try to develop an equation for this y. Okay? So y is equal to, we know that stress, we have in the numerator, we have a stress. What is a stress? Stress is pressure, that is force divided by area. And what is a strain? Strain is change of length per unit length, right? So from here, if I, convert this division into multiplication, the bottom fraction, the numerator, the denominator fraction will be reversed. So L by L. So then it will become F capital L divided by A small l. Okay. Anyone have any doubt here?
No.
So this is the equation to calculate the Young's modulus. Now, in case of a wire, we are considering wire, right? Previously, we saw that the experiment we conducted is for wire. So, for wire, we are hanging the load, right? So, the force that is acting on the wire is equal to the weight of the load, right? So, what is the weight? If I am hanging m mass, then the weight will be mg, right? And we have initial length with it and the area. Generally, whenever we are talking about the area of the wire, it is the cross-sectional area. So cross-sectional area, it is circular. The wires are circular, right? So pi r square into the length change. Okay. So for wire, we can directly use this equation while solving the numerical problems. Okay. Achha. Now, can anybody tell me what is going to be the unit of this Young's modulus? What is the unit?
Newton per meter square.
Newton per meter square. Very good. Okay, why it is Newton per meter square? That is the unit of pressure, right? Okay, we know that longitudinal stress. This is actually stress is pressure. So pressure is Newton per meter square, or we can say Pascal also. And strain, it does not have any unit, right? It does not have a unit. So only Newton per meter square is there, or we can say Pascal. Okay, so elastic modulus, they will have a unit same as pressure. Achha. And kindly go through the dimension. It will have a dimension similar to pressure, right? So kindly go through these things and also read the significance very well. Okay, please go through the significance very well. This is very important. To understand the significance, actually, what I can show you, সিগনিফিকেন্স গুলো অনেকে মুখস্থ করে, আমি চাই না আসলে তোমরা কি মুখস্থ করবে এগুলা। এই যে ইকুয়েশন, এই ইকুয়েশন থেকেই লেখা যায়। যেমন আমি যদি তোমাকে বলি যে ওয়্যারটা আমরা নিছি, এটার এরিয়া হচ্ছে ইউনিট, এটার যে চেঞ্জ হয়েছে লেংথের সেটাও হচ্ছে ইউনিট, এবং এটার ইনিশিয়াল যে লেংথ সেটাও হচ্ছে ইউনিট, then what will happen? Y is equal to will be F. So what is actually Young's modulus? If I ask you to give the definition, you can actually write the definition from here itself. Okay, you will write the force applied on an object of unit area and unit initial length to cause unit length change. Okay, the force, you see, Young's modulus is actually the force applied. But what is the condition behind that? The area of the body has to be unit, the initial length has to be unit, and the change of length that has been caused due to the application of force has to be unit. ওকে, সো এই কথাগুলোকে যদি একটু গুছাই লিখতে পারো না তাইলেই হয়ে যায়, বাট লাস্টে দিয়ে এটা লিখতে হবে। সো ইয়ংস মডুলাস ইজ দ্য ফোর্স অ্যাপ্লাইড, কন্ডিশনগুলো লিখবা অফ দ্যাট ম্যাটেরিয়াল, এই কথাটা মেনশন করাটা ইম্পর্টেন্ট, অফ দ্যাট ম্যাটেরিয়াল। কারণ হচ্ছে কি ম্যাটেরিয়াল টু ম্যাটেরিয়াল ইট উইল চেঞ্জ, উই আন্ডারস্ট্যান্ড ইট, রাইট? আচ্ছা, okay, so kindly go through the significance. I hope inshallah there will be no doubt, but still if there is, then you can let me know in the next classes. Okay, the next two we have time to discuss. Okay, just I will just tell you the similarities with this. Okay, we already saw that Young's modulus is actually equal to longitudinal stress divided by longitudinal strain. Okay, this is for length, but we know that sometimes due to the application of force the volume might change. So for that what we get, okay, the ratio of volume stress divided by volume strain. This is bulk modulus expressed by B, and it is written bulk modulus. So whenever we are talking about volume stress and volume strain, you know that you have to use the equation of bulk modulus. Okay, so now this volume stress also we can express by force by area, because this is stress ultimately. What is the volume strain? The change divided by the original, right, strain. So from here, what you know, from here you can directly write that equation. How? Just remember to multiply the top one and the bottom one. So it will be F into capital B and the middle two. Okay, if I write it properly, then it will be easier for you to understand. F into B, A into B. For MCQ, sometimes it will help you. Okay, so it is the small b, that is the change, and it is the capital B, that is the original volume. Okay, so this is called bulk modulus, and here also the unit is going to be Newton per meter square, because ultimately it is stress by strain only. Okay. Okay, so kindly go through the dimension, unit, and significance of this. And the last topic that we will study today is compressibility. What is compressibility? Compressibility is just the opposite of bulk modulus. Okay, compressibility. Compressibility is equal to the opposite of this, volume strain. Volume strain divided by volume stress. So as it is the opposite of bulk modulus, we can just write 1 by B. That is the opposite of bulk modulus. Okay. So whenever you have to define compressibility, you can just write it is the ratio. But first you need to mention, okay, within the elastic limit, the ratio of volume strain and volume stress. Okay, it's called the compressibility of a particular object. Okay, and it is opposite, reciprocal. Opposite na reciprocal korata better. It is the reciprocal of the bulk modulus. Okay. And as bulk modulus is reciprocal of compressibility, this bulk modulus is sometimes called as incompressibility. Okay, they are reciprocal, opposite to each other. So if this is compressibility, this one would be known as incompressibility. So in numerical example, if you're asked to calculate the incompressibility of an object, then you have to calculate actually the bulk modulus. Okay. Anybody has any doubt? No. Okay, then I would like to request you to go through the next topic, that is modulus of rigidity. We actually saw that three type of stress are there: longitudinal stress, volume stress, and the other one, if you remember, we studied shear stress. Shear stress is something in which the volume doesn't change, the length doesn't change, but what changes? The shape changes, right? So whenever you are applying some stress and it is not causing any change in length or volume, but it is causing the shape to get changed, then this stress is shear stress, right? and due to that shear stress, we will get, rigidity modulus. Okay, so rigidity modulus. Okay, this is shear stress divided by shear strain. Till now, what we saw, Young's modulus is longitudinal stress by longitudinal strain. This is for length. This is for shear. Okay, so shear stress divided by shear strain. Inshallah, we will study about this in details in the next class. Okay. Anybody wants to ask anything before we end the class? And from now on, please try to join from the very beginning of the class, because we are taking attendance. Okay, and it carries some marks. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.